One of the most common NDT techniques is the magnetic particle testing. This method is very commonly used for inspection of carbon steel structures, pipes and pressure vessels. The technique is very sensitive for surface inspection, for detection of cracks and any other defects on the surface. I will give you a brief introduction on this technique right here, and then we have 3 more videos which will show you a demonstration of the MT method. Here we describe the concept of magnetic particle testing. Here is a part with no defect, the flux lines are uniform, and then we have a part here with a crack on the surface. As you can see, what happens to the magnetic field is that the magnetic field is disturbed and the crack produces a leakage field, which is shown right here. Now, what we do with MT testing is that we pick up that leakage field, and how we detect the leakage field is by using magnetic particles. Magnetic particles are sprayed on the surface either in the dry form or suspended in a liquid. Here we see the part with the crack. The crack produces a leakage flux, which is shown here, and then the particles are attracted to the leakage flux area, and that's how we pick up the indication produced by the crack. One thing we have to understand about magnetic particle testing is that it's sensitive to cracks which actually block the magnetic field. So it's very sensitive to cracks which are perpendicular to the magnetic field as shown here. However, if the crack is parallel to the magnetic field, it could be missed and not detected. So MT testing is very sensitive to cracks perpendicular to the magnetic field, and it will also detect cracks which are 45 degrees to the magnetic field. In order to perform MT testing, we have to follow some basic steps. Number 1 is to produce magnetism inside the material, to produce a magnetic field. Number 2 is sprinkle the particles, and number 3 is the evaluation. So the steps are shown here. Applying the magnetic field, we could have either a longitudinal field or a circular field. Longitudinal field goes to the axis of the part, and the circular field goes around the part. The axial field is sensitive to the transverse cracks shown right here, and the circular field is sensitive to the axial cracks, which is shown right here. Now these two fields could be AC, which is alternating current, or DC, which is direct. The main advantage of the AC is that it's very sensitive for surface inspection. AC has a skin effect which produces a very concentrated field on the surface, and that is what we use the magnetic field testing for, is the surface inspection. Now the next step is to apply the particles. The particles can be dry or they can be in a wet medium. The dry particles are just sprinkled over the surface, and the wet particles are actually the same particles, but they are suspended in some kind of a liquid. Now these particles can be visible or they can be fluorescent. Fluorescent particles are actually more sensitive for detection of cracks, especially very tight cracks. Once the inspection is done, and then we have to look for the particles, we have to make sure that there is enough light on the examination surface. If the inspection is done using the visible particles, then the light level has to be at least 1000 lux, and if the inspection is being done using the fluorescent particles, then the light level has to be at least 1000 microwatt per centimeter square for the black light. Let me go through all the basic equipment used for the manual MT using the yoke method. This is a AC yoke. There is a switch here to turn it on. Here is a DC yoke, which is much bigger and heavier than the AC yoke, so it's more difficult to use. The technician who is using the DC yoke really gets tired fast. So the preferred yoke for testing is the AC yoke. In some cases, the yoke can have an additional light right here to get some extra visible light. Here is the 10-pound weight. To check the yoke lifting capacity, we put the yoke here and then we lift it. There are other ways of magnetizing pipes and bars, and for those we need bigger machines, and we use coils which are wrapped around the part to produce longitudinal magnetism, and for the circular magnetism we actually pass the current through the part itself, and that produces circular magnetism. A basic ruler to measure the indications. Now, one thing we have to do is to make sure that there is enough magnetic field in the part being inspected. So we can use either a pi gauge or we can use a shim. In general, the pi gauge is used for dry powder and the shims are used for wet MT. Here are the particles which are used for the testing. Before we apply the particles, we may want to apply a cleaner on the surface, which is right here. The dry powder is right here. There is an air blower to spread the dry powder. Then to perform wet visible MT, we may first apply the wet contrast paint right here, and then the wet visible particles are here. In order to do the fluorescent inspection, then we use the fluorescent particles. These materials are available in various brands in different countries. So whatever is available in your area, you could buy that specific brand. Once the particles are spread out, we have to make sure that there is enough lighting. In order to measure the lighting, we use a light meter, which is right here. And the light meter can be connected. This is a visible sensor, and this is actually a UV sensor for the black light. And the black light is right here, which is used for the fluorescent inspection. So that's about it as far as the equipment is concerned. And in the next few videos which are on our website, you will see the demonstration of all the three techniques, which would be the dry powder, the wet visible, and the fluorescent MT. This was a brief introduction to magnetic particle testing. If you are interested in training, please contact us at our office.